So let's take a look at your first one. You had a 3/7 and you were adding a 2/7 to that. What's nice about this one is what? They're the same, right? They're both 7s. We don't have this issue. So when you have the case of the same denominator, what do? You just add the numerators, right? So if we have the same denominator, all we do is add the numerators. Right? We just add them up. So let's take that concept. Let's move over here to the rationals, and let's look at these examples. So I have a 2 over x minus 4 plus an x over an x minus 4. So an x minus 4, same denominator, right? So we're going to treat that just like we would over here. So if I had that 3/7 and 2/7 you added, you ended up with what? You ended up with a 5 over 7, right? So we're going to do the same thing over here. I have my x minus 4, and I bring together my numerator, so I'm going to add them. I have a 2 plus my x. And let's clean that up. We want to go in descending order, so we would really have, x plus 2 over the x minus 4. We want to always clean them up. We want them all to be in descending order. Okay? So let's look at that second one, that 2x minus 3 over x squared minus 1 plus that 5x plus 7 over x squared minus 1. Same thing, right? We'll carry over, if they have the same denominator of x squared minus 1, so we'll carry that on over, and then we will add those numerators together. So we have a 2x minus 3 plus a 5x plus 7. So we can combine those like terms. Our 2x and 5x would give us 7x, and our negative 3 and 7 would give us positive 4. Okay? Any questions on that? Pretty straightforward, right? Okay, so let's go ahead and take a look at our second one there. What's the difference in 1 and 2? That's subtraction, okay? So, as always, that negative sign will come into play. All right. So I have the same denominator, and so this time I will just do what? Subtract. So if I have the same denominators, I'll run out of room. I will subtract the numerators. So when we get into subtraction, we get into that negative sign, right? So if we come back to our first one over here, we have the 8/11 minus 3/11. So that essentially is our 8 minus 3, which would give us what? 5 over 11. So we're going to carry that concept over here. All right, here's the issue when you are subtracting rationals. You are going to subtract this expression. You're going to subtract this expression, this x plus 9. So when you do that, you're not subtracting just one number like we did here, so we can just bring that on up. You must bring that negative up, and you need to distribute it. Okay? So if we do that, I distribute that negative, my 9x would become negative, my 7 would become positive. Oh, did the wrong one. Oh, well, let's do this one since I'm down there. So now let's combine them. We have the common denominator of 3x squared minus 4. And combine. I have an x and a negative 9x.
Negative 8x plus 10.
And the positive 3 and positive 7. Yes.
And the denominator stays the same?
Mm-hmm. Yeah. They're both 3x squared minus 4. Yeah. So that comes over unchanged. Now let's go back and do the top that I skipped. That top one there. Uh-huh.
So does the negative only get distributed into the second one?
Second one, yes, ma'am. Good question. Yes, the negative only gets distributed into the one that you are subtracting. So let's come back up to that first one that I skipped. So again, we're subtracting. So that x plus 9, you must distribute that negative sign. So that would make your x negative, and that would make your 9 negative. So combine those for me. What do you get?
1x minus 2.
Over our common denominator of
X plus 6.
x plus 6. So whenever you're working these problems, when they're mixed in, addition and subtraction are mixed in, always look at that at the very beginning, so you'll know that you will have to take into account that you will at some point in time have to distribute that negative sign.
Why is there a negative?
No, you're right, it should be. Positive 11 and negative 9. 11's larger, so it would be plus. Yes. Thank you. Any other questions on that? 'Cause I'm going to take... Okay. At number 3, what's the difference between 3 and 1? Now we have to start working with that common denominator. All right. When we want to find our common denominator, what we focus on, remember, is our least common multiple. Okay? We focus on that least common multiple. So if I have, in this case, if I have an 8 and I have a 4, what would be a number, what would be their least common multiple that would represent both the 8 and the 4?
8.
8. Yes, because 8 is a multiple of 8 times 1, right? And 8 is a multiple of 4 because you would get that with 4 times 2, right? So in this case, we would then come over and give them a common denominator of 8. Now my 3/8 is going to be unchanged, right? Because my denominator was unchanged. However, we're going to bring that special 1 back in for that 1/4, okay? We have a 1/4. We want a common denominator of 8, so we have to convert it. So what is that special 1 that we're going to use? What did we multiply with 4 to give us 8? 2. So we're going to have to multiply the 1 also times 2, okay? So when we do that, what are we going to get?
5/8.
So we're going to do our special 1, in this case of 2, and then that will, yes, give us a 2/8. Okay? So let's come back down. The 3, like I said, stayed the same. We're going to add that 3 now to our new 1/4, which is, so we'll add the 3 to the 2 and give us 5/8. So we use our least common multiple when we do not have common denominators. So we're going to take that least common multiple and we're going to use that to find a common denominator. So let's look at it in our rational form. All right, I've got this 5 over 3x plus x plus 1 over x. Okay, I'm essentially going to find the least common multiple that we found over here. Let's take our first denominator. When we are working with rational expressions, here's how you need to think when you're doing these. You need to think to yourself, I have to have both denominators represented in my common denominator. So that's kind of how you have to think of these. So if I look at that 3x, what would represent a 3x? If I have a 3x, what would represent a 3x? How about a 3x? Would a 3x represent himself? Yes. Okay. All right. So if I use a 3x, I will represent this one. Now let's come over here to the x. What do I need to represent an x with? An x, right? So when I look at the denominator I already have, is my x already being represented? Yes, it is. So my common denominator will be the 3x. Now let's come back over here. Your 4 essentially was part of that 8, right? All we really had to do was multiply it by 2 to get that 8. So this is kind of that same concept. The x is a part of that 3x, okay? Just like the 4 was a part of that 8, okay? So we're going to come over now, and we're going to bring over that common denominator of 3x, and we're going to look at special ones. All right, I have 5 over 3x. Did I multiply 3x with anything other than 1 to get a 3x? No. So do I need to multiply 5 with anything? No. So he'll come over unchanged. So I'll just bring him on over as 5. Always notice what your sign is. This is plus, so we don't need to worry about signs. So I'm going to just go ahead and put the plus. Now, this denominator was an x. We now have a 3x. So what do I have to multiply with this x to give me 3x? 3. So our special one will be in the form of 3 over 3, right? So then I'll come over here to this x plus 1, and I'll multiply it with the special one of 3 over 3. So the 3 times x gives me the 3x, and then let's multiply this. How are you going to multiply a 1 times an x? A 3 times an x plus 1. Distribute it. So what's that going to give you?
3x plus 3.
Okay. And now let's clean it up. Go in descending order. So what's going to be our first term? 3x. So we're going to have 3x, and then your constants, your 5 plus 3, so 3x plus 8 over our denominator. Questions on that?
So you wouldn't cancel the 3x?
Okay, we have an x plus 1 over 2x plus 4 minus, so right there, guys, be really careful. You've got a minus there. 9 over x plus 2. Does anybody see anything we can do to these denominators? Yeah. Yep, that 2x plus 4, right? We can take out we have a greatest common factor, so we're going to take out that 2, and that leaves us with x plus 2. And our 9 is over x plus 2. We can't do any simplifying on that, right? Okay, so now we need to come over and represent our common denominator. All right, so to represent a 2, I need a what? I need a 2. And to represent an x plus 2, I need a what? X plus 2. All right, so that takes care of this denominator. That takes care of that 2x plus 4. Now let's come over here. How do I represent an x plus 2? With an x plus 2. Do I have it already represented? Yes, I do. So we're good to go. Okay? So now let's go back and make this good with our special ones. Okay. My x plus 1, do I need to multiply this with anything? No. Did I change my denominator when I moved it over? No, it is still the same. So we can bring that over unchanged. Okay, let's look at our second one. We have an x plus 2. Now we have a 2 times x plus 2. So what do I need to do to the x plus 2 to make this 2 times x plus 2? No. Multiply by 2. Right. I have this, but I need that. So I'm going to multiply by 2. So that's going to be my special 1 here. So I'm going to multiply this second one by 2 over 2. Okay. So that will give me the 2 times the x plus 2 here. And then 9 times 2 would give me what? 18. But it's a what? Negative, so don't forget about that negative. Okay, clean it up.
X minus 17 over 2x plus
We're going to leave it in this format just in case we might be able to simplify. Okay. But it would be the same thing. Yes. All right, questions on that? Different denominators, right? Okay. So, again, we're going to go through the same process. We need to find that least common multiple. Okay? So I have a 7 and I have a 5. What multiple would represent both of them? 35. They will both go into 35. This time we're going to have to change both of them. Last time we only had to change the 1/4, but this time we'll change both. So let's take the 3/7. We're going to use the least common multiple of 35. So let's do 35. All right. So what did I multiply with 7 to give me 35? A 5, right? So do the same up here. 5 times 3, 15. And let's do the 2/5. We're going to convert that to the 35, that least common multiple. What did you multiply with 5 to give you 35? 7. So we must do the same on top. So 2 times 7 is 14. This is addition, so we can add those together. The 15 plus the 14 is going to give us 29 over our common denominator. All right, so let's come over to our rational expressions. Let's apply this same concept over here. All right, I have a 5 over x minus, be careful, minus 2x over 3. All right, I have an x and a 3. What's the least common multiple that would represent them both? What? 3x. Exactly. It's going to pull, the x will be pulled in and the 3 will be pulled in. Okay, so now let's go and make our fractions good. Let's convert them. So I have 5 over x. What did I multiply with the x to give me 3x? What did you multiply with the x to give you 3x? I think I heard somebody 3. So we'll multiply that with the 5. 3 times the 5 is 15. And then minus. All right, what did you multiply with 3 to give you 3x? X. So we'll multiply the 2x as well. So 2x times x, 2x squared would be minus 2x squared. All right, clean it up. Yeah, let's do the negative 2x squared plus 15 over 3x. And our last one. So we have an x plus 3 here, and here we have a 2x minus 1. How do I need to represent an x plus 3? With an x plus 3. And how can I represent a 2x minus 1? With a 2x minus 1. It's that simple. It is what it is. You get what you see. All right, so that's our common denominator. So we've got to make this good. So you have an x plus 3. What did you multiply with it to get your common denominator? You have the x plus 3. You need the 2x minus 1. So multiply that with the 4. What's that going to give you? This is plus, so we don't need to worry about signs. So I'm just going to go ahead and do plus. Okay. You have a 2x minus 1. What do you need? You need the x plus 3. So multiply the 7 with the x plus 3. That would give us... All right, you're good. Clean it up. 8x and 7x. Negative 4 and 21. Negative 17. No, plus 17. Over your x plus 3, your 2x minus 1.